Lesson 2.1 is on combining like terms to solve equations. We look at page 86, example 1. Gianna has 36 yards of fabric to make sets of matching placemats and napkins. How many matching sets can she make? So from the picture, what they're trying to show us is that we need 1 1/3 yards for each placemat, and we need 1/6 of a yard for each napkin. So from that, this would be one way we could figure this out. We could say, if we're going to make matching sets, we're going to make the same amount of each. So if we can just say X is going to be our number of placemats or napkins, we're going to have the same amount of each one of them. We could make up a equation off of that. So 1 1/3 X, 1 1/3 yards times however many placemats we make, plus 1/6 times how many napkins we make, equals 36 altogether. And then they kind of skipped over a little bit here. 1 1/3, we could change that over to 4/3 X. And then these are like terms, a little bit different than what we've talked about. They're like terms, but they are fractions. So we would need to get a common denominator first in order to add those together. So we multiply numerator and denominator both by 2. That's how they got that 8/6 X. At that point, these are like terms we can combine together. That would be 9/6 X. And then the book's doing something a little bit different here. You have two options at this point. What they're doing is multiplying by the reciprocal. When you guys first learned about reciprocals, we said a number, two numbers whose product is 1. In other words, two things, if you multiply them together and you get 1, those are reciprocals. And that was always just with fractions. We did keep, change, reciprocal. The deal is, though, if I can get a 1x, that's the same as x. 1x is the same as x. So when I get to a point like this where I have a fraction coefficient, I have 9/6 right in front of the x, I could otherwise multiply by the reciprocal. 6/9 times 9/6, if you multiply, if you don't reduce, you'll get 54 over 54. 54 54ths, that's the same as 1. 1x, that's the same as x. So that's one way of doing it. The other way of doing it, which is perfectly fine, is we've been talking about opposite operations. So from an opposite operation standpoint, you could say 9/6 is right next to the x, means they are multiplying, and so we could divide. Good. We could divide by 9/6 on both sides. And you might say, well, that doesn't look anything like what they did. Well, just hang in there and watch the transformation. So we have 36 divided by 9/6. 36 we can put over 1. And then remember, dividing fractions is keep, change, reciprocal. At that point, you can go ahead and multiply those and then divide that out. Remember, when you're multiplying, you do have an option of reducing like factors. So if you notice it, the 9 and the 36 are both divisible by 9. We could make that into a 1 and a 4. And then 4 times 6 is 24. 24 over 1, which is the same as 24. So x equals 24. If you look at what they did in the book, they came up with the same answer. And notice what they did. They ended up doing 6/9 times 36. We did 36 times 6/9. So it's the same either way. The other thing is that actually the 9/6, you could reduce that to 3/2. You could reduce that to 3/2 x, and then that would give you a little bit smaller numbers to work with. But anyway, they could make 24 matching sets of placemats and napkins. The other method of doing this, another idea, is you can use a bar diagram. And then another idea, technically, if they don't tell you you have to use an equation, You could just say I need 1 1/3 yards and I need 1/6 of a yard. You could add those together and get 9/6, or I guess that would be 1 3/6, which is 1.5. And that's basically saying you need 1.5 yards for each set. And then you could say I'm going to take 36 divided by 1.5. Okay, if they don't specify that you have to do it a certain way, that you have to write an equation, you can do it this way as well. And you'll get the same answer. Okay? Obviously, sometimes they are going to maybe just say write and solve an equation. In that case, we've got to do it kind of the way that they did in the book that we mentioned earlier. So if we look at the try it, Selena spends $53.94 to buy a necklace and bracelet set for each of her friends. Hope she doesn't have too many friends. It's going to be expensive. Each necklace costs $9.99. Each bracelet costs $7.99. Oh, I read that wrong. $53.94 is what she spent altogether. Sorry. I was thinking that's what she was spending on each person. Okay, anyway, how many necklace and bracelet sets S did Selena buy? So there's different ways you could do this. They're suggesting over here that we do an equation. So if we do an equation, we've got the cost of the necklace. Necklaces would be $9.99 times however many sets we buy. And then the bracelets are $7.99 times however many sets we buy. And then those are like terms that we can add those together. If you add those together, you get $17.98. And then at that point, we could say that they're multiplying, so we could divide by $17.98. When you divide that out, probably for time's sake, I would let you use a calculator for that. That will be 3. So that means 3 sets. So 3 friends that she bought for. This did not specify that we had to do an equation, so another option that you might be more inclined to do would be that you could add the $9.99 and $7.99 together to figure out that the total cost is $17.98 per set. And then at that point you could say she spent $53.94. So if we do $53.94 divided by $17.98, that will tell us how many sets. Again, without even doing an equation, we can figure that out as well.